All right, buckle up everybody, because today we're taking a deep dive into something truly mind-blowing. Black holes.
Yeah, black holes. They're these mysterious objects that really push our understanding of the universe to the limit.
You're already fascinated by these things and want to go beyond the basics, so we're
Yeah.
going to get into some seriously cool stuff. Think of it as Black Holes 2.0.
Exactly. We're going to explore the stuff that truly bends your mind.
The stuff that really makes you question, like, what's even going on out there in the cosmos?
The thing is, black holes are more than just fascinating objects. They challenge our very understanding of physics, of how the universe works.
Okay, so we're not just talking about, like, a giant cosmic vacuum cleaner here.
No, not even close.
I mean, our source mentions that black holes are more like ultimate cosmic rule breakers.
Yeah, that's a good way to put it.
Where do we even begin to unpack that?
Well, let's break down the key features that make a black hole a black hole.
Okay, sounds good.
And that starts with understanding three things: the event horizon, the singularity, and gravity.
Gravity. But like on steroids.
You could say that, but we'll get to that in a bit.
Okay, so the event horizon.
Right, the event horizon, that's where it all starts.
It's not just a fancy name, right? It's like a
Correct.
crucial part of the whole black hole deal.
Yeah, it's basically the point of no return.
Point of no return, huh?
Yeah, imagine you're approaching a black hole and you're getting closer and closer.
Okay, I'm getting closer and closer.
The pull of gravity is getting stronger and stronger.
Oh.
Eventually, you reach this point where gravity is so strong that nothing, not even light, can escape. And that, my friend, is the event horizon.
Like, if you were to cross that line, you're gone, right? No coming back.
Basically, our understanding of physics breaks down at that point. It's like stepping onto a one-way cosmic subway.
Whoa, I mean, that's pretty intense. So if you were to cross this event horizon, hypothetically, of course, what would even happen?
Time dilation for one.
Time dilation?
The closer you get to a black hole, the slower time moves for you, compared to someone watching from a safe distance.
Whoa, that's trippy.
It really is. It's like you're stepping into a time machine, but one with some potentially serious consequences.
Right, and that's just the event horizon. We haven't even gotten to the singularity yet, which, if I'm remembering correctly from our source, is like the heart of the black hole, right?
Yeah, exactly.
Our source describes it as having infinite density. How can something be infinitely dense? Isn't that, like, physically impossible?
It's a concept that really stretches our understanding.
Yeah.
Imagine taking all the matter in a star, something many, many times larger than our sun,
Okay.
and squeezing it all down into a single point.
That is really hard to picture.
It's mind-boggling, right?
Okay, my brain is officially starting to hurt.
That's the thing about black holes. They force us to confront the limits of what we know and maybe what we think we know about the universe.
And then we've got this whole gravity gone wild situation.
Oh, yeah, gravity around a black hole.
Yeah.
It's not your average, everyday gravity.
Like gravity on steroids.
Right, more like gravity on a cosmic power trip.
So you mentioned it warps space and time, but
Yeah.
what does that actually look like? Like, can you paint a picture for us?
Imagine a bowling ball on a trampoline.
Okay.
It creates this dip, right? Well, a black hole does something similar to space-time.
Like it creates a cosmic dent.
Exactly. And the more massive the black hole,
Yeah.
the deeper that dent.
Whoa.
And that warping effect, that's what causes the intense gravity and those bizarre time dilation effects we talked about.
So it's like the black hole is the ultimate cosmic heavyweight champion.
Yeah, something like that.
Warping the very fabric of the universe.
They really challenge our understanding of gravity, space, and time.
So now I'm starting to see why they're considered such dramatic, rule-breaking entities.
Yeah, that's a good way to put it.
But where do these cosmic behemoths even come from?
That's the next chapter of our story. And trust me, their origin stories are just as wild as their properties.
Okay, bring on the drama. I'm ready to hear about how these black holes are born. Our source mentioned different sizes, different backstories. What's the scoop?
So there are a few different ways black holes can form,
Okay.
but let's start with the most common type. Stellar mass black holes.
Stellar mass.
These are born from the dramatic deaths of massive stars.
Sounds intense.
It is. Picture a star much larger than our sun.
Okay.
When it runs out of fuel, its core collapses under its own immense gravity.
Like it implodes.
Yeah, exactly. It's an implosion on a cosmic scale.
Oh.
And this collapse triggers a supernova.
A supernova, like those incredibly bright explosions we see in space?
Yes, it blasts the star's outer layers into space.
Wow, so kind of like a cosmic phoenix.
I like that. Except instead of rising from the ashes, we get a black hole.
And what's left behind after all that cosmic fireworks?
A core so incredibly dense it collapses in on itself and becomes a black hole.
Our source described it as an overenthusiastic hug from gravity, which, honestly, I kind of love.
Yeah, it's a good visual.
Now imagine that whole process, but on a much, much grander scale.
Right.
That brings us to the supermassive black holes.
Supermassive, yeah.
These are the giants lurking at the centers of galaxies, right?
Exactly. Millions or even billions of times more massive than our sun.
Wow, that's almost impossible to comprehend. So where do we even find something that massive?
They're found at the center of galaxies, actually. Even our own Milky Way has a supermassive black hole at its core.
No way! So our entire galaxy is swirling around this giant black hole.
In a way, yes.
Oh.
These supermassive black holes are like the gravitational anchors for entire galaxies.
That's incredible. But our source mentioned their formation is a bit of a mystery, right?
Yeah, it's a puzzle that's been keeping astrophysicists up at night for a while now.
Mm-hmm.
We know they're there, but how they form is still up for debate.
Mm-hmm.
Did they grow from the mergers of smaller black holes? Or did they form directly from massive gas clouds early in the universe?
It's like a cosmic whodunit.
Exactly. We're still piecing together the clues.
Okay, so we've got stellar mass black holes born from the dramatic deaths of stars.
Right.
And these supermassive giants holding galaxies together with their origins shrouded in mystery.
Mm-hmm.
But didn't our source also mention a couple of other ways black holes can form?
You're right. There's also the possibility of black holes forming through the merging of smaller black holes or neutron stars.
Like a cosmic demolition derby.
Exactly. Imagine two incredibly dense objects colliding and combining their mass.
And boom, a brand new, bigger black hole is born.
That's the idea. And then there's accretion, where a black hole slowly but steadily pulls in surrounding matter, growing larger over time.
So black holes can form through these explosive deaths, these epic mergers, or this kind of slow and steady snacking process.
It seems like there are a lot of paths to becoming a black hole. Variety is the spice of life, right? Or in this case, the spice of the cosmos.
Right. But here's what really blows my mind. We're not just theorizing about these objects anymore. We have concrete evidence that they exist.
Yeah.
We're moving from theory to reality.
Absolutely.
And that's where things start to get really, really exciting. Tell me, what kind of evidence has blown the minds of scientists and proved that these cosmic enigmas are the real deal?
Well, one of the most groundbreaking moments came in 2019 when the Event Horizon Telescope, this global network of telescopes working together,
Oh, yeah.
captured the first ever image of a black hole shadow.
Oh, wait, hold on.
Yeah.
We actually have a picture of a black hole.
We do.
I remember when that image was released, it was everywhere. Like, it was all over the news, social media.
It was huge.
It was a really big deal.
It was a monumental achievement and a testament to human ingenuity and collaboration.
Mm-hmm.
This wasn't just a blurry blob. It was this remarkably clear image showing the supermassive black hole at the center of the galaxy, M87.
M87, that's the one. It's
55 million light years away.
55 million light years away. That's insane. That means the light we're seeing from that black hole started traveling towards Earth.
Before humans even existed.
I know, it's mind-blowing. But okay, how do you even take a picture of something that's supposed to be black? I mean, light can't escape it, right?
You're right. Light can't escape from inside the event horizon.
Oh, okay.
But the image we captured actually shows the glowing ring of hot gas swirling around the black hole, just outside that point of no return.
Okay.
That ring is essentially silhouetted against the black hole's shadow, giving us a glimpse of its shape and size.
So it's like seeing the outline of the cosmic monster, even though we can't see the monster itself.
Yeah, that's a good analogy.
It's like a shadow puppet, but on a cosmic scale.
Exactly. And this image provided the most direct confirmation yet of Einstein's theory of general relativity.
Which predicted black holes way back when, right?
Over a century ago.
Einstein was a genius. I mean, there's no doubt about that. But this whole idea of a black hole warping space-time, it's just so hard to wrap my head around. It's like something out of science fiction.
It really does stretch the limits of our imagination, but that's what makes it so exciting. And this is just one type of evidence we have.
Oh, right. Didn't our source also talk about gravitational waves?
They did.
Okay, break this down for me, because I know I've heard of gravitational waves.
Yeah.
But I'm still a little fuzzy on the details.
So imagine two black holes spiraling towards each other, eventually colliding in this massive cataclysmic event.
Okay, I'm picturing it.
This collision sends out ripples in the very fabric of space-time, like ripples spreading out from a stone thrown into a pond.
Okay, I can kind of visualize that. So these ripples, these gravitational waves,
Yeah.
they're carrying information about those black holes, right?
Exactly. They carry information about the black hole's masses, their spins, and how they interacted during the collision.
Wow.
And thanks to incredibly sensitive observatories like LIGO and
Virgo and Virgo.
we can now detect these faint whispers from the cosmos.
Wait, so we can actually hear black holes colliding?
In a way, yes. These observatories are so sensitive, they can detect these incredibly subtle distortions in space-time caused by gravitational waves.
I mean, that's incredible. So we have images, we have gravitational waves. It seems like the evidence for black holes is pretty undeniable at this point.
The evidence is definitely mounting.
But here's where it gets really interesting. Our source suggests that black holes aren't just these fascinating objects in their own right.
Right.
They're also keys to unlocking some of the universe's biggest puzzles.
That's what makes them so compelling. Black holes are like cosmic laboratories that push the limits of our understanding.
Yeah.
They challenge our theories and force us to confront some of the deepest mysteries in the universe.
Like that whole information paradox thing, right?
Oh yes, the information paradox. That's a big one.
Can you give us the SparkNotes version?
Well, it basically asks the question, what happens to information that falls into a black hole? According to classical physics, information should be destroyed.
Gone. Poof.
But that violates a fundamental principle of quantum mechanics, which states that information cannot be destroyed.
So we've got classical physics and quantum mechanics at odds with each other.
Exactly. It's a cosmic clash of titans.
That's heavy. So what's the solution? What happens to the information?
That's the paradox. We don't have a definitive answer yet.
Oh, come on.
Some physicists believe that information might be encoded on the surface of the black hole, like it's imprinted there somehow.
Okay.
Others suggest that information might leak out through something called Hawking radiation.
Hawking radiation, that was Stephen Hawking's idea, right?
It was. He theorized that black holes aren't entirely black.
They're not?
They can actually emit a faint thermal radiation due to quantum effects near the event horizon. And that radiation could potentially carry away some of the information that falls into the black hole.
So it's like the black hole has a cosmic backup system.
In a way, yeah. It's a fascinating possibility, and one that researchers are actively exploring.
So maybe information isn't completely lost after all. That's kind of reassuring in a weird way.
It is. And this brings us to another mind-bending area of research. Quantum gravity.
Oh, quantum gravity. I've heard that term thrown around, but I'll admit I'm not entirely sure what it means.
It's basically an attempt to combine Einstein's theory of general relativity, which describes gravity,
Right.
with the world of quantum mechanics, which governs the behavior of matter and energy at the tiniest scales.
So it's like trying to fit together two giant puzzle pieces?
Exactly.
Except these puzzle pieces represent two of the most fundamental forces in the universe.
And black holes, with their extreme gravity and those quantum phenomena we talked about, are the perfect testing ground for these theories.
Like those black holes are taunting us, saying, come on, physicists, figure me out if you can.
Yeah, it's a challenge that physicists are more than happy to accept. And the best part is, this is just the beginning.
Wait, there's more.
Oh yeah, there's a lot more to discover.
I'm already feeling overwhelmed with cosmic awe. What else is on the horizon in this wild field of black hole research?
Oh, there's so much more. For one thing, we're building even more powerful tool to observe the universe. We're talking next-generation observatories,
Oh, wow.
both on Earth and in space. They're being designed and constructed right now.
So we're talking about telescopes that can peer even deeper into space with even greater clarity.
Exactly. Imagine being able to observe the swirling gas clouds around a black hole's event horizon with incredible precision.
I mean, that would be revolutionary. What about gravitational waves? Is there anything new on the horizon in that area?
For sure. Scientists are working on even more sensitive gravitational wave detectors.
Oh, wow.
They'll be able to pick up even fainter ripples in space-time.
Like, how faint are we talking?
These detectors will be so sensitive, it'll be like listening to the universe with, like, finely tuned ears,
Oh.
able to detect black hole mergers from even further away and with much greater precision than ever before.
I can't even imagine what kind of secrets we'll uncover with that kind of technology. So we're going to be able to hear the symphony of the cosmos with even greater clarity.
Yeah, exactly.
But it's not just about the technology, right? Our source also mentioned some really exciting theoretical developments.
Oh yeah, theoretical physics is buzzing with activity around black holes.
What's the latest and greatest? What can you tell us?
Well, physicists are working tirelessly to develop new models, new frameworks to try and finally crack the code of quantum gravity,
Mm-hmm.
to understand the information paradox,
Right.
to really probe the true nature of black holes. There's
Yeah.
so much we still don't know.
It seems like black holes are not only pushing the limits of our technological capabilities,
Hmm.
but they're also pushing the boundaries of our theoretical understanding of the universe as a whole.
It's this amazing interplay between observation and theory that drives scientific progress.
Yeah.
Every new observation we make provides data that can be used to refine and improve our theories.
Mhm.
And every new theory we develop suggests new observations to make.
It's like a never-ending cycle of discovery.
Exactly. And it's a cycle that's constantly pushing us closer to a deeper understanding of these fascinating objects.
It's pretty awesome when you think about it.
Yeah, it really is.
But with all this talk about advanced technology, complex theories,
Yeah.
I think it's important to step back for a second and just ask,
Right.
why should we even care about black holes?
You know, that's a really good question.
Why are they so important to us?
I mean, they're not just these distant, abstract objects that have nothing to do with our lives.
Mm-hmm.
They actually play a crucial role in the evolution of galaxies,
Okay.
including our own.
Really?
Yeah, their intense gravity influences the formation of stars
Yeah.
and the dynamics of entire galactic systems.
So black holes are more like cosmic architects
Mhm.
shaping the very structure of the universe around them.
And they're more than just architects, they're storytellers.
Okay, how
By
sorry.
studying black holes,
Mhm.
we're learning about the history of the universe, the life cycles of stars, and the fundamental laws of physics that govern everything around us.
It's like they're holding a cosmic library of knowledge,
Mhm.
just waiting for us to unlock its secrets.
And every new discovery brings us one step closer.
It's a pretty amazing thought, that these objects that seem so strange and distant could hold the keys to understanding the universe on a much grander scale.
It really is.
But I think perhaps the most important reason to care about black holes
Yeah.
is that they represent the ultimate frontier of human knowledge. They push us to think bigger, to be bolder, and to question everything we thought we knew.
They force us to confront the limits of our understanding
Mm-hmm.
and to push past those limits in search of something new.
They inspire us to be curious, to explore, and to never stop asking questions.
And that's what science is all about.
Well, this deep dive has been quite the journey. We've explored the truly mind-bending properties of black holes.
Mhm.
We've heard the dramatic stories of their formation. And we've even gotten a glimpse of the cutting-edge research that's helping us understand these cosmic enigmas better than ever before.
We've journeyed from the familiar laws of physics to the very edge of the unknown.
Mm-hmm.
And along the way, we've encountered some of the most profound mysteries of the universe.
I don't know about you, but I'm feeling a renewed sense of cosmic wonder. Black holes might seem like strange, distant objects, but they're a reminder that the universe is full of surprises, mysteries,
Yeah.
and endless possibilities for exploration. I mean, who knows what we'll discover next?
As our knowledge and our technology continue to advance, who knows what incredible secrets we'll unlock. The future of black hole research is bright, that's for sure.
Well, on that note, we'll leave you to ponder the mysteries of the cosmos. Keep exploring, keep questioning, and keep your eyes on the skies. Who knows what wonders are waiting for us out there? Thanks for joining us on this deep dive into the world of black holes.